Hello students, welcome back. Our last lecture we tried to discuss about the potential differences or the polarities across different elements of a circuit. Now in this lecture we will try to differentiate between the point voltages and potential differences across many elements in a circuit. So before going into the details of our circuit, let us have a scenario. So suppose you have to go through three shops. This is shop number 1. Okay, this is shop number 2. This is shop number 1. This is shop number 2, and let's say this is shop number 3. Okay, so you have to go through these three shops. This is 1, this is 2, this is 3, and the rule here is that whatever rupees or whatever you have to consume all the bags here, so that when leaving from the last shop you would have no bucks or no money. So suppose you have here $100. Okay, so suppose you have $100. You now enters the first shop, and here you consume almost 20 bucks, $20 here. Okay, by leaving this shop, now you have here, let me use this color here or change it. Yes, okay. So by leaving this, now you have only $80 in your pocket. Okay, after it you enter this shop, and here you consume, let's say, $30. Okay, when you consume $30 after leaving this shop, how much money would you have? You would have 30 out of these 50. You will have now $50. Okay, after it you enter this shop. Here you have to consume the overall money, because the rule is when coming out of the last shop you should have nothing in your pocket. So you will consume $50 here, and when you will reach this point you will have nothing in your pocket, and this is the overall scenario. So you can see here that this shop was a little bit expensive, this was also expensive, but this was not that much expensive. This is the overall scenario in which you have some money, you enter some place and consume that money into those places. Okay, so this was the shop example. Suppose similarly you have a circuit which is composed of 3 resistors, this one, this one, and this one. Okay, these have some resistances. This is R1, this is R2, and this is R3. The resistor it has is, let's say, this is 10 ohm, this is 15 ohm, and let's say this is 50 ohm. Okay, when you connect a voltage source here, plus minus, and the value of this voltage source is, let's say, 100 volts. Okay, let us give this the same value here. So when you will use it and use this voltage source, and you will have to find out the voltage drops here, and someone asks you what will be the voltage drops here, you will say that it will be, let us say, okay, let us remove the values here. Let me remove the values here and use it like an hypothetical circuit. So the voltage drops here will be, concept is like the same. This is 24 volts here, here 30 volts, and here we have 50 volts. Okay, what will be the polarity, which we have discussed in our last section, which was plus minus when we consider clockwise current direction. This will be like this one, and this one. these are the voltage which are dropped here, and it is similar like this shop and money problem. Okay, so these are all the scenario. Now the problem is how to find out, if someone asks you what will be the voltage here at point A, what will be the voltage here at point B, what will be at C, and what will be at D. How would you find it out? Okay, it is basically the same problem. Whatever we have solved here will also be applied here. This is the 100 voltage, 100 will be here, 100 volts will be here because nothing has been consumed. Now the current has entered through this resistor. It will consume 20 volts, and at the end what will be left here, the value which was here, which was the total value while entering minus the consumed value. So what was that value? 100 minus 20, so it is 80 volts. Now here we have 80 volts. At point B we have 80 volts. Similarly, when this 80 volt is here, it has come here, the current has passed through this resistor. Now 30 volts are consumed. What will be the value at at C point? That would be again now 80 minus 30, the value of money which a person was entering a shop minus the value which was consumed was equal to $50. Similarly, here we have 50 volts. Similarly, when it enters through this one and leave it, the value here at D will be equal to 50 minus 50 volts which was consumed, and it is 0. It is, we have made this rule. Similarly, the same rule has been applied here by KVL. KVL says that all the voltage which a source has will be consumed across all the circuit elements available in a circuit, and at the end we will have them equal. I mean Vs minus Vr1 plus Vr2 plus Vr3 up to Vrn will be equal to 0. So that's why I have told you this rule here, and I have shown you that from the last resistor, all the voltage which was at its one end will be consumed, so that it will obey this equation number A. So this was the basic concept in finding the point voltages and potential differences at all the points A, B and C. These are the point voltages, while at the other points which are these are called potential differences, because we can see here that Vr1 is equal to Va minus Vb. Similarly, Vr2 is equal to Vb minus V of C, and Vr3 is equal to Vc minus Vd. By putting values here, we can see it very clearly that we can very easily find out the value which is consumed when a person was entering a shop and leaving it. This was the potential difference. Similarly here, 80 volts minus what was the voltage at C, this was 50, so the consumed voltage was 30 volts. And similarly here, 50 volts minus 50 volts, sorry, so 50 volts minus 0 which was at point D, so it was basically 50 volts which was consumed. So all of these are basically the potential differences or the voltages which were consumed by different resistors. So I hope the concept is clear now.